Hello friends, let us start with the next experiment. First of all, welcome to Switchgear Lab at YCC. This is the directional relay CDD26. Okay, so this is the experiment, directional overcurrent relay. This is the directional overcurrent relay. I have opened the cover of this relay, and the terminals of this relay, those are present at the back side of the relay, have been taken from the fronts over here, and they've been labeled over here. So terminal number 7, 8, 9, 10. We require only 4 terminals, so those will be used in this experiment. Now, let us start. Let us start with the supply. So this is the 3-phase supply. This 3-phase supply is given to the switch ICTP, ironclad triple fold switch. Then the fuses are there. After the fuses, there is a phase shifter. After phase shifter, the 2 terminals from the phase shifter, they goes to V1 and V2. V1, V2 goes to 7 and 8. 7 and 8 are the potential coil terminals. So the impedance of this 7 and 8 is usually high. Across this 7 and 8, V and V2, we are having a voltmeter connected in the range of 0 to 110 volt. Next, the N goes over here, and V, this is the second terminal over here, another dimmerstat. So this V goes to ammeter, ammeter goes to rheostat, and rheostat goes to terminal number 9 and 10. Between 9 and 10 there is a current coil, and 10 number goes to back to the neutral over here. So this is the circuit diagram for the directional overcurrent relay. Now let us see the actual circuit over here. So on this table we are having the PVN as shown in the figure. We are having PVN. Now if you look, we are mentioned over there is a phase shifter. Now for phase shifter we are using the induction motor. So we already know that induction motor is a rotating transformer. So if I remove the rotation from there, what would happen? It will act like a transformer. So we are using the induction motor as a phase shifter. The supply is given to the input of the motor, and the output of the rotor, okay, the single phase of the output of the rotor is taken from here, and it is given to V1, V2 directly over there, and from V1, V2 we shall be giving to 7 and 8 over there. So basically we are using slip ring induction motor. Out of the 3 phase of the secondary side of the rotor, we are only using the single phase, and the single phase of those rotor terminals through slip rings have been taken out at V1 and V2. If you look over there, this is my V1 and V2. On this V1 and V2, the input comes here from the back side of the rotor terminals. Okay, across V1 V2, the voltmeter is connected internally, and this V1 V2 goes to the 7 and 8. This 7 and 8, they are nothing but the potential coils. Next, a dimmerstat is over there, and this dimmerstat PVN. V goes to ammeter. This is ammeter. We are using the range of 0 to 2 ampere. Okay, from ammeter, the second wire, the red wire, goes to rheostat. Again, the secondary of the rheostat. Remember again, rheostat has to be kept at the maximum position. Okay, so secondary of the rheostat, it is the green wire. This green wire goes to terminal number 9 over there. This is the current coil. Okay, and the 10 number, the yellow wire, it goes to back to the neutral over there. And to measure the phase shift across this voltage and current, since we are using directional overcurrent relay, this directional overcurrent relay will operate when the current operates in a particular, when the fault occurs in a particular direction. And so, to observe the phase angle between the voltage and current, a CRO is connected across the V1 and V2. So V1, V2, this is the CRO over there. Okay, it is a double channel oscilloscope, the CRO. And we are also observing the current waveform. So for current waveform, we are using the V and N terminal over here. The reason behind using the V and N is that this is the V and N, this is the current coil, this is a supply voltage. Next element is ammeter. Ammeter has got 0 internal resistance. Therefore, if you connect across V and ammeter, it will not show you any reading. Similarly, 9 and 10, there are the current coil. Again, if you connect across 9 and 10, again it will not show any waveform over there, because again it is ideal, the impedance is 0. Either across the rheostat or either across the dimmer, it will show you the waveform. So I am preferring to go with the V and N over there.